Okay, so what we're looking at here on the 2017 example of a polar equation is one, you'll get to use your calculator, so that part's not that big of a deal, but there is some stuff going on here that is a little bit more, I don't want to say complicated, because the problem starts off innocently enough. So let's just jump in and take a look. Okay, so we've got the figure above shows the polar curves r equals f of theta equals 1 plus sine theta cosine of 2 theta, and r equals g of theta equals 2 cosine of theta for the region between 0 and pi halves. Let r be the region of the first quadrant bounded by r equals f of x. So it basically tells you that this is the f of theta, not f of x, f of theta function right here. And then S is the region bounded by the two curves, okay? So it's got g of theta out here. And that's kind of important for us to understand. You could use your calculator to find that out, but it would take time to graph both of those. It is nice that they're telling us it's between 0 and pi halves, so that's going to help us out a little bit, okay? So the first one wants to know, okay, find the area of R. Well, remember, if I want to find the area of a function between the origin and wherever the curve exists, I just do the integral from 0 to a to b, so in this case from 0 to pi halves, with the 1/2, and then we take our function, so in this case that's f of theta, and we square it. And then we just put that into our calculator. When we do that, we get 0.648. So that one's pretty straightforward. There's only one function there, so you don't need to make that one overly complicated. Hopefully that one made sense. Letter B says, okay, the rate theta equals k, where k divides from 0 to k, k is between 0 and pi halves, divides S into two regions of equal area, right? But do not solve an integral involving one more equation involving one more integrals whose solution gives the value of k. Now basically what this is saying is we're going to draw a line out in this direction that makes it so that this area is equal to this area. So what we're really saying is we need to do an integral from 0 to whatever that ray is of 1/2. The two functions subtract each other, so I'm going to have g of theta squared minus f of theta squared. Remember, we do the further radius minus the closer radius, d theta. And then that's going to equal the integral from whatever that ray is all the way to pi halves of the exact same stuff. So I've got 1/2 g of theta squared minus f of theta squared. When we set it up like that, then, oops, I forgot my parentheses right there. Then hopefully that makes sense, because what we've done is we just set them equal to each other. There, you don't have to solve it. You just have to realize this. If I knew what that value was, it would make those two numbers be exactly the same. And we don't know what that is, and that's okay. Letter C says, let w of theta be the distance between the two polar coordinates. And remember, any distance, regardless of how you're doing it, a distance between two different functions is always one function minus the other function. That's what tells us the distance between two things if we plug in the same theta. So there's my expression of w of theta right there. Then it says write an expression for that. Then it wants the average value of that on the interval from 0 to pi halves. Well, average value, we do the integral from 0 to pi halves of that distance that we're talking about. So I'm going to go g of theta minus f of theta. Then I've got a d theta on the end. And then we divide that by how big the interval is. In this case, that's pi halves minus 0. Which just, when I put all of that into my calculator, it does take a little while to type that in, but when you type that in, you get 0.485 or 0.486. That gives you your average value on that particular interval, okay? The letter D says, using that information, so that 0.485 that we just barely got, find the value of theta for which w of theta, so again, that's g of theta minus f of theta, find the value at which that is equal to that average value that we just found, 0.485. Okay, so you put that into your calculator and you find out that happens at 0.517 or 0.518. It rounds up to 0.518. So that is where they're equal to each other. Now it also wants to know, is the function increasing or decreasing? So what we have to do is we have to take the derivative at that particular value and plug that in. And if that number is positive, then it's going to be increasing. If that number is negative, then it's going to be decreasing. And it just so happens that at that time, it is less than 0. You just put it in, it's less than 0. So we can say that it is decreasing as well. The only problem I thought was really difficult on this one was actually letter C. It was a little bit tricky asking you what it wanted you to do. Other than that, it was a lot of just applying formulas. So if you have any questions about this one, please let me know.